An ordnance sergeant figured out that he could weld two big prongs on the front of a tank, and they'd dig into the hedgerow, and the tank would shove its way right through a hedgerow. And after we got that, made it a lot simpler.
On July 14, 1944, Sergeant Curtis Grubb Culin III, a 29-year-old tanker with the 102nd Cavalry Reconnaissance Squadron, mechanized, 2nd Armored Division, watched General Omar Bradley step out of a jeep near Saint-Lô, France. Culin knew the next few minutes would decide whether his improvised device could help thousands of American tanks break through the deadly Normandy bocage terrain. Culin had no formal approval yet. He had spent only the past few weeks testing his invention. In the 6 weeks since D-Day, the U.S. First Army had lost hundreds of Sherman tanks while struggling against the bocage. These were not simple hedges. They were ancient earthen embankments, often 10-15 feet high and several feet thick, built up over centuries from fieldstones piled by French farmers along property lines, with dirt accumulation and dense root systems reinforcing them into natural fortifications. When American tanks attempted to climb over these barriers, their thinly armored bellies, about 1 inch thick, became exposed. German anti-tank teams with Panzerfausts, or 80 mm guns, targeted this vulnerability from concealed positions. Most Sherman crews perished inside their burning vehicles before escaping. Culin's unit had been patrolling bocage country since late June. The tactical math was grim. Each battalion fielded around 70 tanks, with only a handful of specialized M4 dozer tanks equipped with bulldozer blades for breaching. These dozers were slow and became immediate priorities for German gunners. From D-Day to mid-July, American forces advanced only about 8 to 10 miles inland, with thousands of bocage fields still blocking the path to open countryside. At the current pace, breaking out could take months. Operation Cobra, the planned armored breakout, demanded fast movement through this terrain, but no effective solution existed. Engineers had tried explosives packed into hedgerow bases, but blasts made little impact and drew artillery fire. Some crews welded spare tracks to hulls for added protection against small arms fire, but it proved useless against close-range anti-tank weapons. Culin cut and welded sections into pronged assemblies attached to a tank's front hull plate. The prongs, angled forward, dug into the hedgerow base rather than allowing the tank to climb over it, enabling a ground-level push-through without exposing the belly. Initial tests on lighter vehicles succeeded repeatedly. A heavier M4 Sherman test, volunteered by crews from the 747th Tank Battalion, also worked after reinforcements. The device added moderate weight but held under impact. Word reached Bradley's headquarters. On July 14th, he arrived for a personal demonstration. He selected a formidable hedgerow. A rhino-equipped Sherman, crewed by experienced tankers, positioned itself, accelerated to around 20 to 25 mph, and struck the base. The prongs bit in, dirt erupted, and the tank burst through in seconds without damage or exposure. Bradley reacted with astonishment, immediately ordering mass production, using available beach obstacle steel and welders across Normandy. He aimed to equip as many First Army tanks as possible before Operation Cobra, set for July 25th. Ordnance units scrambled. Enough steel existed for hundreds of devices. Welders worked around the clock, adapting design slightly. Production challenges included torch limitations and weight distribution issues, resolved through reinforcements and shifts. By July 25th, approximately 500-600 Culin devices equipped about 60% of First Army's Shermans, Stuarts, and tank destroyers, roughly 3 out of every 5 tanks in key units. Operation Cobra launched with massive aerial bombardment, followed by armored advance. Rhino tanks punched through hedgerows in 15-30 seconds each, allowing rapid cross-country movement. German defenses, built around forcing tanks to climb and expose vulnerabilities, collapsed. Advances that once took days occurred in hours. Failures happened, but the rate stayed low compared to prior losses. The devices neutralized bocage advantages, accelerating the breakout by weeks, reducing tank casualties significantly, estimates of hundreds of tanks and thousands of crew lives saved, and enabling pursuit across France. Bradley later praised the absurdly simple invention in his memoirs, A Soldier's Story, naming Culin and describing the demonstration. The device became standard in training manuals. Culin received the Legion of Merit for his ingenuity. He continued serving, suffered wounds later, including leg amputation, and returned home in 1945. He married, worked in sales for Schenley Industries in New York, and lived quietly until his death on November 20, 1963, at age 48. In 1964, on the 20th D-Day anniversary, former President Dwight D. Eisenhower recounted the story to Walter Cronkite on CBS television, filmed in Normandy bocage country, crediting Sergeant Culin by name for solving a problem that stalled the Army. The Culin hedgerow cutter remains a classic example of battlefield innovation, a sergeant's practical fix using enemy materials that helped turn the tide in Normandy and saved countless lives. Museums like Fort Knox and the National Wport Museum preserve rhino-equipped Shermans, honoring this forgotten but pivotal contribution. In the summer of 1944, during the Battle of Normandy, Allied forces, particularly the Americans, had become bogged down fighting the Germans in the Normandy bocage. This landscape of thick banked dirt and rock walls covered with trees and hedges proved difficult for tanks to breach. In an effort to restore battlefield mobility, various devices were invented to allow tanks to navigate the terrain. Initially, the devices were manufactured in Normandy, largely from German steel beam beach defensive devices on an ad hoc basis. Manufacture was then shifted to the United Kingdom, and vehicles were modified before being shipped to France. The devices have been credited with restoring battlefield mobility in the difficult terrain, a claim which some historians question. Following the Normandy landings of June 1944, as Allied forces pushed inland from the French coast, they found themselves operating within an area of Normandy's countryside, known as the bocage. The actual bocage landscape extends further than the limited definition of bocage normand, that is to say, from the area directly west of Arromanches-les-Bains, including the entire Cotentin Peninsula, to the south of Brittany, Maine, and Vendée. In some areas, this terrain stretches for 50 miles. This landscape contained large earth dikes averaging 4 ft, 1.2 meters, high, that were covered with tangled hedges, bushes, and trees that surrounded small raised irregular-sized fields, which were generally no more than 300 ft, 91 meters, across on a side. The nature of the hedgerows, sturdy embankments, half earth, half hedge, up to 15 ft, 4.6 m, high with sturdy interlocking root systems, made excavating them extremely difficult, even with machinery. Narrow sunken roads were the only pathways between these banks. Tank movement was severely restricted, preventing the Allied forces from bringing their vehicular superiority to bear. The rolling landscape was also dotted with small rivers, woods, and fruit trees, along with scattered stone farmhouses and their outbuildings. Allied infantry, in particular the Americans, found themselves fighting from field to field against the Germans, who had in many places dug foxholes directly into the hedgerow embankments, providing their machine gunners and riflemen protection from overhead artillery fire. These defensive positions limited the ability of the American forces to coordinate large-scale attacks or receive sufficient and accurate artillery support. Openings that did exist within the patchwork of hedges were already covered by German anti-personnel and anti-tank weapons. Armor moving through these gaps attracted immediate defensive fire. Tanks were able to push their way over the hedgerows, but in doing so they exposed their weak underside armor. Tactical developments throughout June involved combat engineers using explosives to blow holes in the hedgerows for tanks to move through. However, the explosions often attracted immediate German attention. Prior to the launch of Operation Cobra, solutions were developed for how tanks could effectively support the offensive within this terrain. Bulldozers or tanks modified to carry a bulldozer blade were used to open gaps in hedgerows. Some hedgerows were so thick that engineers first had to blow a hole in the bank, which a bulldozer would later clear and widen. This time-consuming process slowed down the progress of the Allied offensive and was compounded by the problem of the conspicuous bulldozers and dozer tanks being targeted by German gunners to deny the Allies a means to break through. Throughout July, innumerable inventions were created by various American units to get tanks through the hedges quickly without exposing their weak underside armor. A hedge cutter developed by the 79th Infantry Division was in operation by 5 July, and a few days later, 19th Corps demonstrated a set of prongs that had been initially developed to create holes for the placement of explosives. The force of these prongs was able to lift and remove a portion of the hedgerow, enough so that the tank would be able to push on through to the other side. Units within V Corps also invented devices, which were dubbed brush cutters and green dozers. The invention of a hedge-breaching device is generally credited to Curtis G. Culin, a sergeant in the 2nd Armored Division's 102nd Cavalry Reconnaissance Squadron. However, Military historian Max Hastings notes that Culin was inspired by a Tennessee hillbilly named Roberts, who during a discussion about how to overcome the bocage, said, "Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges?" Rather than joining in the laughter that greeted this remark, Culin recognized the idea's potential. A prototype tusk-like assembly was created by welding steel scrap to the front of a tank to create a hedge cutter. The teeth helped prevent the vulnerable underside of the tank from being exposed while it knocked a hole in the hedgerow wall. On 14th of July, Lieutenant General Omar Bradley inspected the tank and watched in awe as a hedgerow exploded to make way for the Sherman bursting through. According to Hastings, Culin, an honest man, attempted to give credit to Roberts, but this was forgotten in the publicity surrounding the invention. Hastings concludes, became a very American kind of national hero. The American official campaign historian, Martin Blumenson, notes that Bradley, impressed, ordered the device be manufactured in quantity. Initially, this was done using steel salvaged from the thousands of obstacles, such as Czech hedgehogs, that the Germans had placed on the French beaches during the construction of the Atlantic Wall. Bradley also dispatched Colonel John Madaris of the United States Army Ordnance Department back to the United Kingdom to have tanks modified before being shipped to France, and arranged for additional arc welding equipment and crews to be transported to France by air. Around 500 of the assemblies, called the Culin Rhino device or Culin hedgerow cutter by the Americans, were manufactured. These devices were used to modify nearly 3/4 of the U.S. 2nd Armored Division's M4 Sherman and Stuart tanks and M10 tank destroyers in preparation for Operation Cobra. The British Royal Electrical and Mechanical Engineers referred to the devices as prongs and produced 24 from ex-German beach defenses. But thereafter, prongs were produced in the United Kingdom. 600 Mark I prongs were delivered by August to be fitted to the Sherman 5. A further 1,000 Mark II prongs were produced to be fitted on Shermans and the M10, and 500 Mark III prongs were manufactured for the Cromwell tank. The Churchill tanks were not considered to need the prong, but some were equipped with them nonetheless. War correspondent Chester Wilmot wrote after the war that the German defensive plan to halt any American breakout was to hold the front line very lightly and to concentrate upon holding the road junctions for a depth of 3 or 4 miles behind the front, with the intention of delaying any breakthrough by reducing the speed of the advance to the pace the infantry could manage. Once Operation Cobra was launched, Allied troops were able to bypass the German positions using the Rhino tanks, thereby allowing the advance to continue, leaving the strong points to be dealt with by infantry and engineers. Blumenson describes how during the launch of Operation Cobra, tanks with the 2nd Infantry Division, supported by artillery, advanced without infantry for 20 minutes, covering several hundred yards and knocking holes in hedgerows before returning to their starting position. The tanks and infantry then advanced rapidly together, before the Germans were able to re-establish their defensive positions. During Operation Bluecoat, British Churchill tanks, equipped with prongs, were able to traverse terrain considered impassable to tracked vehicles, taking the German defenders by surprise. Military historian Stephen Zaloga claims that the devices were not as widely used as the legend would suggest, nor were they as effective as is often believed. But Max Hastings and Chester Wilmot credit the invention with restoring battlefield maneuverability to the Allied force. Martin Blumenson states that while the device restored mobility in hedgerow country, it was of little tactical value in the breakout, except possibly as a morale factor to the troops, since the tanks advanced on the roads, not cross-country. Blumenson, Martin, 2005, 1951. Breakout and Pursuit, United States Army in World War II, the European Theater of Operations. Washington, D.C., Center of Military History, United States Army, ASIN B0031, 3 IYQ0, OCLC 12533744. Archived from the original on 31st October 2011. Buckley, John, 2006, 2004. British Armour in the Normandy Campaign, 1944. London, Taylor and Francis. ISBN 978-0415-407731. OCLC 1546992. Doubler, Captain Michael D., 1988-1955. Busting. The Bocage, American Combined Arms Operations in France. June, 31st of July, 1944. Combat Studies Institute. Archived from the original on 2nd December 2010. Retrieved 15th of March 2012. Fletcher, David, 1993. The Universal Tank, British Armour in the Second World War, Part 2. London, Her Majesty's Stationery Office. ISBN 978-0112905-349. Harrison, Gordon A. 2002, 1951. Cross-Channel Attack, United States Army in World War II. Washington, D.C., Center of Military History, United States Army.